Alright, let's do this. Hello and welcome to this video. The topic of this video is about using the QGIS Task Manager with the fromFunction method. In a previous video, I explained how to use the method from a processing algorithm, which is limited at the usage of processing algorithms built in QGIS. In this video, I show the fromFunction method and still use a processing algorithm as an example. This will allow beginners to better understand the code structure of the code, although in addition I will add a for loop iterating over a few features to demonstrate how this could be implemented. Let's head over to the code structure. Here you can see the skeleton of the code. First, I'll explain this one, then add more and more code to the different blocks. The basic structure consists of three functions and an algorithm block. The first function is the function which is doing the work of our task. Here we call it your function. The second function is called when the task is stopped by the user. The third function is called when the task is finished or raises an exception. Let's hope the latter doesn't occur. At the end, we have the algorithm block. Here we declare a QGIS task object using the method fromFunction. Then we pass the task to the task manager. Once this happens, the task manager will call your function, which is declared here inside the object, and this function will run. After this function is completed, here the function in the parameter onFinished is called, in this case, the function completed. I will now show you the same code structure with some additional elements. Let's start in the algorithm block. The first few lines are getting the layer with the name 3.fromFunction QGIS task from all the layers shown in our map canvas. This means that the input layers consist of only the layers ticked here in our layers panel, which are shown here in the map canvas. For instance, if I untick these layers, they won't be taken into account. So be sure to tick the layer which you want to have as an input for your function. In the second code block, we are defining the parameters we will pass to your function and could then be used in the processing algorithm. We'll come to that later. After this, we create a task object, which we then pass to the task manager. Let's now check the code block of your function. First, we declare a variable. Here we pass a string to the variable output layer for demonstration purposes. Then we have a useful code block when working with the task manager. This block allows us to cancel the task. Here we have a simple demonstration of a for loop. We iterate over the numbers 0 to 9. There is written 10, but the function range stops at the second argument -1. At each loop, we declare a variable printed number, which is equal to number, this one, plus 1. We wait for a certain amount of time. The variable wait time comes from here, parameter of the function. In our case, that will be 0.5 seconds. Then we print the number. After this, we insert the option to cancel the task inside the for loop. And at the end, we build an output result. In this case, it's a Python dictionary. Finally, we return the result of the function. As explained earlier, if the task is cancelled by the user, the function stopped is called. In this function, it's useful to print a message to the log messages so that we are informed about what happens in QGIS. If the function your function finishes completely or raises an exception, the function complete is called. Here the different cases are handled. Your function did not raise an exception and has a result or has no result. Here there is no result and here there is a result. And also if your function did raise an exception. I won't talk about exceptions here because those mean that we didn't get our result, and that is what we would like to have. Although, in case an exception is raised, it's useful to print an informative message to the log messages panel in QGIS so that we get an idea of what happened in the machine. So the code block where we have a result is this one. In this case, we print the entire result declared earlier for demonstration purposes and demonstrate how to access the value of the key output layer here. Now let's see how this intermediate code demonstration runs. Heading over to QGIS, here we open the script we want to run. You can browse from here or you can copy paste into an untitled script that works fine as well. So let's run this and then we see 1, 2, 3 and always a waiting time of 0.5 seconds. The result dictionary is printed and then we have the string, just some string for demo, which we declared earlier here as the variable, as the value of the variable output layer. Now let's run this code again and show how to cancel a task in the task manager. It's pretty straightforward. Here you go here and you cancel the task you want. In this case, there was no message in the log messages because we didn't configure that, but we will show later how this would show up here. Now that all the elements of the code have been explained, let's dive into the complete code when using the fromFunction method to create a QGIS task. Starting again from the algorithm block, there's nothing new here. Let me just quickly explain the parameters we are setting. So as the input key, we take the value input layer taken from here. The field name is our output field name in the attribute table of the layer. The field type is 2. 2 means string. The field length is 254. We have a field position of 0. This parameter is only used for decimal values when declaring a field type of decimal value. Then we add a formula. This one, I explained it in the previous video. And then we declare an output key with the value memory and some layer name plus output. To get the documentation on processing algorithm inputs and outputs, you can use the following line in the Python console from QGIS. So let's do this, copy paste, we go to QGIS, you insert this code here, the command line here, and you hit enter, and then you get a lot of information about what input and output parameters you can use for the processing algorithm. For instance, if you need to know the value of a float, here it's 0. So if you want to declare a float field, you hit 0 here. For instance, we keep 2 because we want a string as an output. Moving up to your function, we start by printing a message to the log messages indicating the user that the task has been started. I left the if is cancelled block in case you find it fancy. This line calls the processing algorithm with the parameters we declared earlier and stores the output in the variable processing output. The processing output is a dictionary with a key called output and the layer we want as a value of that key. So to get a variable corresponding to our output layer, we access it like this. I think it's useful to show how to loop over the features in a layer, so I will be showing this code block how it works. So for every feature in our output layer, be sure to get the features with this method. We print the value of the attribute ID geoport. Then we increment the variable iterations declared earlier here. And in this code, for demonstration purpose, we break out at 10 iterations. Usually what you want to do is loop over every feature in your layer, but here and for debugging and testing, you can break out at some given number of iterations. Then we insert the if is cancelled block, which allows us to abort the task without waiting the end of the for loop. At the end, we build our result dictionary and return it. Quick side note, here is a demonstration of an error message printed in case the stopped function is called. Moving on to the completed function. In this code version, we added log messages to all the cases like exceptions raised or missing results, but also add successful results like here. Let's just accept that these log messages exist, are important or useful, and move to the final magic of our code. And this is the part where we add the output layer to our map canvas and finally print a message to the console telling us that we did it. Let's finally run this code and have a look at the result. Heading over to QGIS, we select this script and then we run it from here. So let's run the script and see what happens. Click run, task manager is busy, you could stop the task here. First the processing algorithm was running and now we printed the 10 first items for the 10 first features with the ID geoport attribute value. Then we have the result here. It was loaded to the map canvas. Let's have a look at the attribute table. Here we go. So here is the field we added using the processing algorithm. And this was the attribute we printed using the for loop. As you can see, the first 10 values match but the algorithm isn't looping over in this order, it loops over in the order of the ID of the features. Now you know how to work with the QGIS Task Manager using the fromFunction method. I hope that my explanations were clear and easy to understand. I tried to make this content beginner friendly. If you need further explanations or you're interested in another aspect of the QGIS Task Manager, don't hesitate to make use of the comment section. There is the third section, the third method to use the task manager. That's by extending the QGIS task object. I'm not sure if I'll make a video about it because for now all the uses I had with the task manager are covered with the fromFunction method. So yeah. Anyway, if you're interested in a video about this method, leave a comment and I'll try to find a time to make one. Now, before finishing, I would like to remind the online documentation available on this topic. So this is the official documentation page from QGIS. Then you have some documentation from opengis.ch, where they go a little bit deeper in the explanation of the QGIS task than on the official uh, QGIS documentation. Finally, the last code I showed in the video, so the complete code with the for loop over the features, is on my GitLab page, which I created especially for this video series. The links to these resources will also be available in the description. And now all that is left to do is wish you a lot of fun exploring the new skills you learned in QGIS and Python. See you and have